In the vast expanse of the universe, there are places where the laws of physics break down. These are black holes, mysterious cosmic objects with gravity so powerful that nothing can escape, not even light. But what are black holes, and why are they so fascinating? Let's find out in the next 5 minutes. Hey everyone! Today, we're diving into one of the universe's greatest mysteries, black holes. From their formation to how they warp space and time, black holes are as strange as they are powerful. So let's get started. A black hole forms when a massive star reaches the end of its life. Stars are powered by nuclear fusion, which balances the inward pull of gravity. But when a star runs out of fuel, it collapses under its own weight, leading to a supernova explosion. If the remaining core is massive enough, it keeps collapsing until it becomes a black hole, a point in space where gravity is so strong that nothing can escape, not even light. The boundary around a black hole is called the event horizon. Once you cross it, there's no coming back. Beyond this lies the singularity, the point where the star's mass is crushed into an infinitely small space, and the laws of physics, as we know them, break down. Not all black holes are the same. There are 3 main types: stellar, supermassive, and intermediate. Stellar black holes form from collapsing stars and are the most common. They typically have masses 10 to 20 times that of our Sun, but they are incredibly dense, packing all that mass into a space just a few kilometers wide. Supermassive black holes are found at the centers of galaxies, including our Milky Way. These giants can have the mass of millions or even billions of suns. Scientists believe they play a key role in the formation of galaxies. Intermediate black holes are the least understood. They fall between stellar and supermassive black holes, with masses ranging from hundreds to thousands of times the mass of the Sun. We've found only a few so far, but they could hold clues to how black holes evolve. One of the most mind-bending aspects of black holes is how they affect time. According to Einstein's theory of general relativity, the massive gravity of a black hole warps space and time around it. If you were to get close to a black hole, time would actually slow down relative to an observer farther away. This effect is called time dilation. For someone watching you fall into a black hole, it would look like you're moving in slow motion, and as you approach the event horizon, you'd appear to freeze in time. But for you, time would seem normal. This makes black holes fascinating not only for astrophysics, but also for theories about time travel. But let's be clear, falling into a black hole would stretch you out in a process called spaghettification. So it's not exactly the kind of time travel you'd want to experience. Since black holes don't emit light, how do we even know they exist? We can detect them by observing how they affect nearby matter. As gas and stars spiral into a black hole, they heat up and emit X-rays, which we can detect with telescopes. In 2019, we even captured the first ever image of a black hole in the galaxy M87, about 55 million light-years away. This monumental achievement confirmed what scientists had theorized for decades. Black holes are some of the most powerful and mysterious objects in the universe. They challenge our understanding of physics, stretch the fabric of space and time, and may hold the key to unlocking the deepest secrets of the cosmos. Thanks for joining us today on this incredible journey into the unknown. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more deep dives into the wonders of space. Until next time, keep looking up and exploring the cosmos.